All right, so for what we're doing today, you're going to need a couple things. Number one, you need your bell ringer. Everyone's going to need their bell ringer, and it says there's the week 4 bell ringer at the top. Okay, so everyone needs a week 4 bell ringer. You don't have these, they're new. Okay, the second thing that you need is everybody's going to need a vocab book, and they're either going to be blue or yellow, depends on which class you're in, because I ran out of some papers, so I had to have 2 different colors. Either blue or yellow book. And the third thing you're going to need is there's a worksheet that says how many solutions. Okay, these are the 3 things that you're going to need, so make sure that you have those before this video begins, because you're going to need all of them today. Okay, so you all should have your bell ringer out, so we're going to look at Monday's bell ringer problem. We're going to look at Monday's bell ringer problem. So we have to solve the equation for x. We have negative and then 7x plus 18 equals negative 2/3 times 6x minus 6. If I'm solving for x, that means I need to draw my line. I need to label my sides, x's, and everything else. I have some parentheses over here on the left side, but there's not a number in front. So what number is that going to be that's going to be in front of the parentheses if I don't actually have one there? Yeah, it's a -1. So I'm going to distribute that -1 in. So -1 times 7x would be a -7x. And -1 times positive 18 would be a -18. Equals, and I'm going to, what do I do on the right side here with this -2/3? Okay, I distribute. -2/3 times 6x. Use your calculators if you need to. Okay, that'd be -4x. And then -2/3 times a -6. So what happens if I multiply a negative times a negative? That's going to give me a positive. That's important. And then it's going to be +4. Okay, so now I just got to make sure everything ends up on the correct side. So I need to move things around. Well, I've already got my sides labeled. So what's something that's in the wrong place? Okay, the -18. When I move that, it becomes a +18. Good. So I'm going to move that over, mark it out. Okay, what's something else that's in the wrong place? Yeah, the -4x. So when I move the -4x over, it becomes a +4x. Good. Okay, so then I can combine my like terms. I can do my math. So what is -7x plus 4x? What is -7x plus 4x? Yeah, that'd be -3x equals, okay, what about the other side? What is 4 plus 18? Yeah, that's going to be 22. Okay, so to get x completely by itself, what do you do now? Yep, divide both sides by -3. So you get x equals 22 divided by -3, or 22 over -3. That would be your answer to that problem. And your other question says, which the graph below represents y as a function of x. So you have 2 graphs. I'm going to very quickly draw these. Be very terrible looking, but you'll get the idea. One looks like this, and the second one looks like this. So which of these, the first graph or the second graph, is a function? Good. The first graph is going to be a function. Why is that? Yeah, because if you draw a straight line, you should only touch the graph one time. And if you look at the right graph, well, I drew a line, and it touched it 1, 2, 3, 4, 5 times. So that made it not a function. If I drew a line on the other one and I touched it, I would only touch it one time. Okay, so it only has one intersection there. So that's why that second graph, or that first graph, is a function. All right, so we are going to be doing our last vocabulary book today. So your vocabulary books are already pre-stapled together for you, and they should be coming around right now, or you maybe already have them. And we are going to title them Systems of Equations and Inequalities. So again, the books should already be stapled together, so you don't have to worry about that. When I draw these, what I'm going to do, and you'll see this on the next page a little better, is this box right here represents one page in my book. So like when you open the book up, you know how it's 2 pages. In a second, you're going to see I'm going to have 2 boxes there. So on the front page of your book, I want you to write Systems of Equations and Inequalities. If you need markers, map pencils, crayons, feel free to get those. There's plenty up there at the front. but I'm not going to have you guys sit in groups today simply for the fact that I am not there. So I want to make sure that y'all are working. Okay? So again, make sure you're writing systems of equations and inequalities on the book there. All right, so if you open your book up to the inside, obviously, we have 2 pages there. So I'm going to write on the left side first. So on the left side, we are going to write what the word system of equations mean. Okay, a system of equations. All right, so in the middle, system of equations. What that means is that you have 2 equations. And if you have 2 equations, that means that you have 2 lines. Okay, so a system of equations means that you have 2 equations, you have 2 lines. To give you a picture, we're going to draw a system here. This would be, oh, that was a terrible line. There we go, that's better. This would be a system of equations, because that's a graph. That's 2 lines. Or I could have something like y equals 2x plus 4 and y equals negative x minus 5. This would also be a system because this is 2 equations. So we could have 2 equations or we could have 2 lines. Either way, that gives us a system. If you look at the other side of your paper, okay, so looking at the other page in this part of the book, on this side we're going to write solution to a system of equations. We're going to talk about what it means to be a solution to a system of equations. And at the bottom, I want you to draw a line across, and I want you to create 3 boxes. Okay? So at the bottom, I want you to draw a line across there, and I want you to create 3 boxes. We're going to write something in the middle, but we're going to draw something in these boxes down here. So when we're looking for the solution, we are looking for the intersection. That's what we are trying to find. We are looking for the solution to a system of equations. We are looking for the intersection. We are looking for a point, and x and a y value. Now, we have a couple options. So down here in the boxes, we're going to draw some things. The first thing we're going to do is we're going to draw an example that has 1 solution. If something has 1 solution, that means that you have 2 lines that intersect 1 time. So this point right here that I'm coloring black would be our solution. That point where those 2 lines met is our solution. It is also possible for us to have no solution. So that's going to go in our second box that we made at the bottom. It's possible for us to have no solution. Well, what would that look like? Yeah, it means you have 2 lines that don't intersect. So this system would have no solutions because there's no intersection. What can you tell me about lines that don't intersect? Yeah, they're parallel. Okay? And our third option is that we can have what is called infinite solutions. And we've talked about this before. This is not new information. You've heard this phrase before. Infinite solutions. What that looks like, and this is going to be really hard for you guys to draw, so just look at what I draw and then you can figure out how to draw it. Okay, so infinite solutions is when you have 1 line, but then you have another line. And that other line is right on top of the line that you already had. So you have 2 lines that are on top of each other, that are really the same line. Okay? So you have 2 lines that are the same. That is when you have infinite solutions. Don't worry, I'm going to zoom back out so you can see this page. And these are our three options for solutions to a system of equations. Okay, so I want you to open up to the next page. All right, we're looking at the next page. And on the next page, I want you to write linear inequalities. Okay, I want you to write the words linear inequalities. And I'm going to give you an example so you're like, what does that even mean? So up here I'm going to write a couple examples. I'm going to write y is less than or equal to 4x plus 5. And I'm going to write y is greater than 2x plus 5. These are examples of linear inequalities. And what makes them different is there's two things. So why are they different? Because number one, sometimes we use a dashed line. And sometimes we use a solid line. So we either use a dashed line or we use a solid line. It depends. And we're going to talk on the next page how we know which one we're going to use. But sometimes we use dash, sometimes we use solid. And the other thing that makes linear inequalities different is that we either shade up above the line or we shade down below the line. So we either use a dashed or solid line or we shade up or down. It depends on what the symbol is, which way we shade and which line we use. And again, on the next couple pages, like in a second, we're going to look at how we know which symbol tells us, or how we know which line to use and which way to shade. So now I want you to look at the right half of this page. Okay, so we're going to look at the right half of this page. And I want you to write a really big S. Okay, you're going to write a really big S. And we're going to write three things here. We're going to write solutions are in the shaded area or on the solid line. Solutions can be in the shaded area or solutions can be on the solid line. So I'm going to give you some examples of what that means. We're going to look at two graphs. So I want you to draw two x and y axes. Okay, two x and y axes on your page. I'm going to label them x and y just because we don't always label them, but I know that sometimes we forget that. So x and y and x and y. And I'm going to draw on one of them, I want you to draw a solid line, and I want you to shade below that line. And then on the other one, we're going to draw a dashed line. And we're going to shade above that line. When we're talking about shading above, that means, what that means, just so you know, is if I were to draw an arrow straight up from the line, that would be my shaded area. Okay, so we're going to talk about what it means to be points. So I'm going to give you some examples of points. Okay, so anything in these yellow areas that I shaded, these would be solutions. Okay, anything in the yellow area would be a solution. So all these points that you see I have in blue, these are all solutions. Because we said solutions are in the shaded area or they're on the solid line. So that means that for the graph on the bottom, I could also have points that are on the line. If they were on the line, they would be considered solutions. Okay, so I think it's also helpful to see things that are not solutions. Okay, so I'm going to tell you my solutions, I colored blue. Okay, my solutions I colored blue. And then my not solutions, I'm going to color those in green, and then I'm going to put an X over them, okay? So my not solutions would be things that are not in the shaded area. So all these dots right here, these are not solutions because they are not in the shaded area. So not solutions, not solutions, not solutions. These points are not solutions. That also means that points on my line here, this dashed line here, these points would also not be solutions, not solutions, not solutions. Same on my other graph. I'm going to put a couple. And you don't have to put this many, okay? Just put like 2 or 3. But I'm just giving you a lot because I want you to see that solutions are in the shaded area and non-solutions are in the not shaded area. So those are what it means to be solutions of a linear inequality. Okay, they're points that are in the shaded area or they are on the solid line. Alright, so on our next page, so again it looks like this. I want you to, on the left side, I want you to split that into 4 quadrants. I want you to split that into 4 quadrants. And in the first one in the top left corner, I want you to draw a less than symbol. Less than is the one that's made with your left hand. And then in the one next to it, we're going to write the word less than. So we're just going to label what it is. We're going to do this on the next 4 pages. We're going to do each of our 4 symbols on the next several sets of pages. So again, on the left side we have the less than symbol, which is made with our left hand. Then we have the word less than down here. And when we graph a less than, we use a dashed line. When we graph a less than, we use a dashed line. So a line that looks like this. It's going to have dashes in it. Or we also use an open circle, depending on what the situation is. And most of what we're talking about this week, we're going to need this dashed line idea. But I don't want you to forget that just a less than means that when you have talking about domain and range stuff, it's going to be an open circle. And over here on the right side, I want you to write that we are going to shade down. You shade below the graph. Okay? You shade below the graph. So those are on the left side of our paper. So we have a less than symbol. We have the word less than, just so we know that's, hey, that's what that symbol means. Then when we graph it, we use a dashed line, or we can use an open circle. And then we shade down, or we shade below the line, and that's how we end up with our graph. So on the right side of our paper, over here on the right side of our flip book, we are going to list some key words for less than, some words that we're going to be looking for in word problems that mean less than. So I want you to write less than at the top. And then some ways that you might see, some wording you might see that means less than is you might see the word is below. It is below. Okay. You might also see the phrase smaller than. So that's a word in a word problem that would mean less than, you would say smaller than. Or maybe you would say fewer than. So again, fewer than is a word in a word problem that would mean less than. Another way you could say that would be lower than. And the last option there for less than would be, like you might see the phrase beneath. So all of these right here are just vocabulary words that mean less than. So these words may show up in a word problem. When they show up in a word problem, they tell us that we need to use a less than symbol. So is below, smaller than, fewer than, lower than, and beneath. On the next page, we're going to do the exact same thing. So we got our book open. On the left side there, I want you to draw your quadrants again. And our next symbol that we're going to draw is a greater than. Okay, question, is a greater than symbol made with your left hand or your right hand? Good, your right hand is your greater hand. So we're going to make a greater than symbol. And then we're going to write the word greater than there because that's important that we know that it's a greater than. So we got our symbol, we got our word greater than, that tells us what that symbol is. Down here in this box, when we use a greater than symbol, do we use a solid line or a dashed line? Good. Again, we use a dashed line. Okay, so it's going to require a dashed line. So we're going to draw a dashed line there. And is it open circle or closed circle? Good, it's still open. When do we use a closed circle? Yeah, we use that closed circle when we have that equal to, which we're going to do those next. And then last question, when we shade with our greater thans, if things are greater, are we going to shade up or are we going to shade down? Good, we're going to shade above the line or we're going to shade up. Okay, so that should be what the left side of your booklet should look like. Okay, and then we're going to move to the right side. And then on the right side of the book, again, we're going to write the word greater than at the top, and I'm going to give you some words, some vocabulary words that you might see in word problems that would mean greater than. The first one I'm going to give you is the phrase more than. When you see the word more than, that means that you should be using a greater than symbol. Okay, when you see the word more than, that means that you should be using a greater than symbol. Another word you might see in a problem is you might see the phrase above or the word above. So if you need to make above $500, you need to make greater than $500. You might see the word over. Again, like if you need to make over 100 on a test, then you need to make greater than 100 on a test. You could see the phrase larger than. Okay, you could see the phrase larger than. You might see the word exceeds. E-X-C-E-E-D-S. The word exceeds. Like if you need to exceed something, you need to do better than something, you need to do higher than something. Or you might see the word higher than. So that's another phrase, or the words higher than. You could see the words higher than. So those are all the different things that you could potentially see. That would mean that you need to use a greater than symbol. Okay, and flipping over to the next page. Again, on the left-hand side, we're going to draw our quadrants. They don't have to be perfect, by the way. There's our 4 quadrants, and we are going to do a less than or equal to. Is a less than or equal to made with your left hand or your right hand? Good, it's made with your left hand. So less than or equal to, and then we're going to write that in the box. It is less than or equal to. Okay. Then in the bottom left corner, when we graph our less than or equal to, do we use a solid line or a dashed line? Yeah, we use a solid line. So we're going to do our solid line. We're going to write the word solid line, then we're going to draw a solid line. And then when we are going to remind ourselves that could also be seen on a graph as a closed circle. Okay, it could be seen on our graph as a closed circle. And our final thing is, which way do we shade? So if it's less than, Are we going to shade up above the line, or are we going to shade down below the line? Yeah, we're going to shade down. We're going to shade below the line. Okay, then we're going to flip over to the other side. And we've got some words for less than or equal to. So I'm going to write that, less than or equal to. And we have some vocabulary words that we can put in here. So one of those words is at most. And this is probably the most confusing one of all. Well, actually, then the next one is too. But if you have at most something, like your first thought is, oh, most, I need to use a greater than. But you don't. Because if you're saying that at most you want something, then you want actually less than that. Like most is the highest it can be. That means what you actually want needs to be less than what that is. Another word that you could have is the word maximum. The word maximum in a word problem would mean that you're going to use a less than or equal to symbol. You could also have the word no more than. So you could have the phrase no more than. So all of these words, despite the fact that they all have like most or more or highest, they don't mean greater. All of these phrases mean less than. All of these phrases mean less than because they mean that like this, whatever is in your problem, that's the biggest thing you want. So what you actually want is something that's smaller than that. You want something that's less than or equal to that. All right, I'm looking at the next page. Same thing. We got one more inequality symbol to go through. One more inequality symbol. So we're going to draw our line, our quadrants in there. Oops, didn't mean to do that. So there's my quadrants. And our final inequality symbol is a greater than or equal to. So we're going to write that in, that it is greater than or equal to. And when we graph this, do we do a solid line or a dashed line? Yes, it is a solid line. And the easiest way to remember that it is a solid line is because this right here is solid, so our line needs to be solid as well. And would that be an open circle or a closed circle if we were looking at domain and range stuff? Yeah, it'd be closed. Very good. So it'd be a completely solid filled in circle. And our last thing, which way are we going to shade? Are we going to shade up or are we going to shade down for things that are greater? Yeah, things that are greater or things that are above the line. So we're going to shade up or we're going to shade above the line. All right, and then if we look at some of our words here for greater than or equal to, so I'm going to move over to the next side of the page, and we've got greater than or equal to. Greater than or equal to. And just like the last one, we have three phrases that we're going to write down here. We have three phrases we're going to write. And our first phrase is at least. When you see the phrase at least, that means that you want to write a greater than or equal to symbol. And our second phrase is the word minimum. If you have a minimum, then that means that you want to use the greater than or equal to symbol. And our last phrase is the phrase no less than. The phrase no less than. So if you want no less than something, then that again means that you want greater than or equal to that something, whatever that is. So those are all of our inequality symbols. All right, and our very last thing that we are going, oh, sorry, not the very last thing, I lied, not on purpose, but the next to last thing that we're going to talk about is, so you have this whole page open, and I want you to write across the whole top, solutions of systems of inequalities. All right, solutions of systems of inequalities. So I need to write that all the way across the top of that whole back page. And then we're going to draw some graphs. So solutions of systems of inequalities. Okay, on the left side, I want you to draw an x and a y axis. Label them x, y. I'm going to draw two inequalities. I'm going to draw one. So here's my first one. Solid line, and I'm going to shade down. Then I'm going to draw my second one, dashed line. And I'm going to shade up. And when we're talking about solutions to a system of inequalities, we're looking for so solutions are this time in the double shaded area. They're in the double shaded area. So I'm going to highlight that in blue on mine. So it'd be all of this area right here, because that's the area where the blue, the red and the yellow overlapped. So all these points in here would be solutions. All these points in here would be solutions, because they're in the double shaded area. And points on this red line would also be solutions, because that line is solid. But points on this yellow line right here would not be solutions, okay? So these points would not be solutions. I'm going to put an X there. They are not solutions, okay, because they're on a dashed line, and dashed lines don't count. So solutions to a system are points that are in the double shaded area. And then on the other side, okay, on the other side, again, I want you to draw an X and a Y axis. And we're going to draw, and you got to pay attention to this, so I'm going to draw a red line. Yeah, yours doesn't have to be red, solid line. I'm going to shade down. Okay, and then my other line I'm going to draw a dashed line. And watch this. Notice they don't touch. It's important yours don't touch either. I'm going to shade up. This problem would have no solutions. And the reason that it would have no solutions is because there is nowhere that these shaded areas overlap. They are never going to touch. And why are these areas never going to touch? What can you tell me about that red and that yellow line? Yeah, they're parallel. So these places are never going to touch, so that means that there are no solutions to this one. All right, flip over to the very, very, very back. And at the very top, I want you to write how to solve an inequality. Oops. Inequality. Just so you know, I spelled just as much for me as I spell for y'all. How to solve an inequality for y. So in our example that we're going to use is we're going to use 4x minus 3y is greater than or equal to 8. We're going to talk about how do we solve this for y. Okay, well, I solve it the way I solve everything else. I draw my line. I label my sides. So y's and everything else. And the question I'm asking myself is, what's on the wrong side of the line? Well, that 4x, I need to move it. And what happens when I move this 4x from the left side to the right side? Good, it's going to become a negative. Okay, so then it's gone. Okay, what do I do next? Yep, I'm going to divide everything by -3. Okay, so here's the only thing with these inequalities. When you divide by a negative, your inequality sign flips directions. So this isn't going to be greater than or equal to. It's going to be a less than or equal to. And then 8 divided by -3 is a -8/3. And if I have a negative divided by a negative, that's going to give me a positive and 4/3x. So I just want you to make a note here that says, if you divide by a negative, you must, that's important, flip the direction of the inequality. If you divide by a negative, you must flip the direction of the inequality. Okay, that's all I got for you. You have a worksheet to work on. It's super simple, super easy. It just asks you how many solutions does stuff have. So it's talking about systems of equations. So go back and look and see how many solutions it's going to have based on what you have in your notes. Thanks, guys.